Hello and welcome. My name is Amir, and today we are going to take a look at the puzzle on day 12 of the Advent of Code 2023. So let's go and see what's the puzzle about. So in this puzzle, we have a input like this, which represents two kind of springs. These are the working one and these are the broken ones. And we have space here and some numbers here. Now these numbers represent these. So when we have one, which means that here we would have one broken spring, and here 1 means this one is broken and 3 means these 3 are broken, and they need to be consecutive, so we cannot have a hashtag here in between, so it would make it 1 and 5. But the input is not so simple and like this, but it's more something like this. These question marks can be either a working spring or a broken one. So in this case, in this very case that we have on line 1, the only possibility is that this is a broken and this is broken, so that we could have 1, 1 and 3. But for example, in this case, this should always be broken, so this should be a hashtag to make this 3 correct. And to make this one correct, we need to have one of these two correct. And they cannot both be correct at the same time, and they cannot be both broken at the same time. So one of the two options. So two options we have here, and for this one we only have two options as well. So it's like 4 different options here to make this number work. For this one, all of these 4 question marks should be broken so that it works. So there is only one way to make this. And we need to resolve the number of these, and I think we need to add them together, the sum of those broken ones. So we could have a brute force here to solve this puzzle. So because the number of the input for part 1 is pretty small, but that won't work for part 2 because the example would get insanely big. So that will not work for that one. We need to come with a better idea. And that idea is basically called the dynamic programming. So how does this work? We would come here and, for example, grab one of these inputs. Let's say, for example, this one. And I would go here to my sketchpad and show how does this work. So if I go to T here and then paste it here, and grab this part, let me make it a bit bigger, and the same goes here. Now we would start by getting different chunks of input. So for example, in the beginning we get one character, only one character, then we get 2 characters, then we get 3 characters, and so forth, and we would run it through this number. So let me make it a table like this. So we have I values, these are the I values, and these are the J values. J can be 1, then can be 1, and then can be 3. So we have 3 options for J, and I can run from 0, which is this one, can be 1, which would be these two, can be 3, which will be these 3, and so forth. So for example, if we are in a case that the I is 1, 2, 3, 4, 5, 6, 7. Let's make it this one. This would be much easier. So if I is here and we have this chunk of the input, something like this, and we are at J1, so at this index and this index, we need to figure out how many times we can make this and this work. So we need to say dot and then question mark and then another question mark and then 2 more dots and then a question mark and 1 work. How can we make this work? Well, there is only one way. This question mark should be 1, and this question mark is either here, this one is either here or here. So there are 2 ways to make this work. And then we would go on from this part. So that's basically the whole idea behind this. I'm just scratching the surface on dynamic programming. It's like a huge topic, and it wouldn't, of course, fit in just a very small video like this one. So this is basically the way to do it. And of course, it's clear that for some cases, we just don't need to do any computation. For example, if I is 0 and we are here and our index is just a dot, no matter what the j is, we have no way of making that. So for example, if we have a dot here and we have 1 and we are here, so this would be like a 0 way to do this. So we would have a big table for each of these input, and in the end we could calculate the number of ways that we could have for this input and these values to work. Now if we go to the code itself, it's been implemented like this. So at the beginning we just, as always, split the numbers, get the numbers and the dictionary. This dictionary is that values that we have here, these ones. It might be better to have a better name here. And the thing is that this calculate will be called bunch of times, and then we would, as I described, go for the I from 0 to the number of the values that we have here, these ones, and for j, which are the numbers going from 0 to the length of that one, we would calculate the possibilities that this could work. And in the end, we would just add the number in the end of that table. So, as I said, the one that we have here for this dot and this tree is the result that we need to return in the end. This is about for part 1. As I said, we could use the brute force, but it wouldn't make sense for the part 2. So I just wrote it again using the dynamic programming for part 1. And in part 2, it's basically the same thing with a small twist, and that is that if we have a input like this, we need to repeat it 5 times. So this chunk will be repeated 5 times, and we need to add a question mark in between them to make a huge string like this, and then 5 times these values should be repeated. So already it would make a huge string that cannot be resolved by the brute force. As we are using the dynamic programming, the only thing that we need to solve is just here and make the dictionary and the number 5 times bigger by just having this for loop here, and that's basically it. And in the end we would just get the result as we did beforehand. I wouldn't go much into details about how the smaller parts of this code work, but as always, you can go to the GitHub channel, get the code and work on that one. So yeah, this was a brief description about how the puzzle is going to be solved on day 12. I hope you have enjoyed the video, and if that's the case, please provide a like, comment, and or subscribe to my channel. Thank you for watching. I'll see you in the next video.